All right, welcome to the fourth episode of Old and Broke, where we break down the financial system before it breaks you. Today, we're diving into something that sounds like science fiction, quantum computing, and more specifically, the quantum chips from Microsoft and Google that are shaking up the tech world. We're talking about Microsoft's Myron A1 chip, which is supposedly based on a brand new state of matter, and Google's Willow chip, which solved a problem so fast it's making scientists question the nature of reality itself. Yeah, it's that wild. Let's break down what these chips are, why they matter, and whether we're really getting closer to the era of practical, world-changing quantum computing. Let's start with Microsoft's Myron A1 chip. Microsoft claims this chip is built on an entirely new state of matter, something topological. We're all familiar with solids, liquids, gases, and plasma. But Microsoft is adding a new one to the list, topological matter. This chip uses one of the strangest particles ever theorized, the Majorana fermion. What makes the Majorana so special? It's its own antiparticle. Think of it like a coin that has no heads or tails, just the same on both sides. No positive, no negative, just itself. That unique symmetry makes it highly resistant to decoherence, one of the biggest problems in quantum computing. See, regular qubits are fragile. They can be in a superposition, both 0 and 1 at the same time, but even a tiny disturbance from the environment causes them to collapse. It's like trying to balance a soap bubble during a hurricane. But Majorana fermions, they're far more stable. Microsoft says they've learned to braid and fuse these particles along a nanowire, engineered atom by atom. That lets them perform quantum operations while dramatically reducing errors. The result is what they call a topoconductor, a hybrid between a superconductor and a semiconductor that could be scaled to millions of qubits. Right now, it's early stage and experimental. But if they can scale it, this could be as big as the invention of the transistor. That's what took us from room-sized computers to smartphones in our pockets. And this might be what takes us from fragile quantum toys to real useful machines. Now let's talk about Google's Willow chip. Willow is a 105-qubit quantum processor that just achieved something called quantum supremacy. That means it performed a task so complex that no classical computer could realistically compete. In this case, it ran a random distribution benchmark, generating a complex entangled output that would take a classical supercomputer around 10 septillion years to calculate. Willow did it in under 5 minutes. Let that sink in. Now, the benchmark itself doesn't have real-world use. It was designed to push the limits, but it proves something important. Quantum computing is starting to deliver. And here's where things get weird. Some physicists believe quantum computers might be tapping into parallel universes. There's a theory called the many worlds interpretation that says every possible outcome of a quantum event happens, just in different universes. So when Willow solves a problem, it might be exploring every possible solution across these realities, then collapsing all of that into the answer we see in our universe. It's not just science fiction. This idea was proposed by physicist David Deutsch, and while it's still debated, it's taken seriously by some in the quantum community. Of course, others stick to the more traditional Copenhagen interpretation, that it's all just probabilities and there's no need for extra universes. But either way, Willow's performance is fueling the debate, not just about performance, but about the fundamental nature of computation and reality. Now, before we imagine quantum gaming PCs or uploading our consciousness to the cloud, let's talk about the challenges. Both Microsoft and Google are still dealing with major roadblocks. The biggest? Scalability and error correction. Quantum systems are delicate. Google has made progress, but we're still far from having millions of stable, error-corrected qubits. Microsoft's topological approach is bold, but still early. It's a long-term bet, and so far mostly theory and lab-scale experiments. So, why does any of this matter? Because quantum computing could touch every major industry. Faster drug discovery, unbreakable encryption, advanced AI, more accurate climate models, even simulating entire worlds. Quantum computers won't replace classical ones. They'll do things classical computers can't even attempt. So here's the big picture. Microsoft's Myron A1 is a bold physics experiment with long-term potential. Google's Willow chip is delivering jaw-dropping performance right now. Both approaches are pushing us forward. Both face serious hurdles, but both are worth watching very closely. Are we tapping into multiverses with quantum chips like Willow? Or is this just brilliant engineering? And can Microsoft's Myron A1 really scale to millions of qubits? Let me know what you think. This is Old and Broke, where we see the cracks before they break. Stay sharp.